So thank you very much for joining me here on stage. We already got a bunch of questions in advance. So we already heard from Stellantis and also from Analog Devices previously about the scalability, about the changes, about going with the ECUs, reducing ECUs, going towards high-performance computers. So as we are, and I would like to start like we have started this block of sessions here from the OEM point of view with one of the questions. So are we truly collapsing ECUs at the moment, or are we just moving some of the complexity towards some of the zones? Or what is your idea from the OEM point of view?
Yeah, simple. We are truly reducing the number of ECUs. I mean, Emily really outlined that, especially from the ADAS perspective. But that's true also in cockpit today, right? We see in both. If we look at like current Grand Wagoneer as an example, it'll have a standalone instrument cluster, a standalone radio, a standalone rear entertainment system, a standalone surround view system, a standalone driver camera, a standalone smart forward camera, right? If we look to the next generation, if you look at the press releases that we just announced as part of Capital Markets Day, you'll see a very significant consolidation of those actual ECUs into very large HPCs.
So I'm just going to continue in that direction. From your point of view also, we heard from Prem, his ideas, his direction is also, where do you see the direction going?
Yeah, I definitely see a strong tendency toward centralization, and Emily and Daniel outlined the reasons for that very well. But there's one additional thing that's going on here, and that is that the hardware platform for the vehicle, as Emily stated, is not tied to function anymore, right? It's a platform that enables software, right? It gives you massive amounts of compute, it gives you communication bandwidth, and it's tied to the cloud. And when you think about where compute needs to sit, it can sit not just in the car, not just in the central compute, but also in the cloud. And you know, this is one of the major decisions that you got to make early on. What should sit in the cloud, what should sit in the central compute, and then what should sit closer to the application. And I'm sure we'll talk about why later.
Yeah, awesome. From the OEM point of view, when we look in the global landscape, we also see the same trend, looking at many OEMs. Centralization is definitely happening. It can see in multiple ways. There are different types of centralization. So one time in the heavy compute area, where you see cockpit, ADAS, and so on in one package or close to each other, or even on single chip. We see that coming in one side. But at the same time, in the lower layers, where you can see the body and the gateway, so on, there is also an amount of centralization happening based on how the inputs architecture in the vehicle is being designed. In total, you can see centralization still across the vehicle. The number of ECUs is going down, number of modules are going down, but at the same time, the compute needs are going up. So you still have challenges with the heat, which is brought in when you bring in all those ECUs to one big central compute. You have the heating challenge, and then typically on an ICE vehicle, that becomes another problem to solve for.
Let me just stick with that one for a second, because you, from the tier one point of view, you work with, on one side, with a lot of the semiconductor suppliers, as well as on the other side with the OEM. So you're basically, call it the meat in the burger, in the sandwich, put it that way. And whatever you do, it's going to be right, or whatever you're going to do, it's going to be wrong. So it doesn't matter. One of the things we have seen also is a complete difference in, let's say, the scalability from level 2 to level 2++, level 3. I'm not talking level 3 for the moment. Let's call it level 2 to level 2++. Do you see a centralization also for the lower end, like Emily outlined, that there is a big difference between the, call it entry level or lower end versus the higher level of autonomy?
Okay, so you can see different ways still. Typically the centralization component on the highest end is not that easy, because the volume for OEMs, when you look at the L3s, L2++ right now in many OEM cases are on the higher premium cars, let's say $80,000, $100,000 cars. At that point, centralization is not a crucial factor, because the cost of car is not where you save anything more. But it's always in this low to mid-term you see the bigger thing, whether you centralize to reduce for cost. But on the higher end, centralized to reduce for the compute centralization, making this vehicle software heavy, it is still applicable at that point. So we see a trend depending on which OEM you look at. There are different ways they look at it. Like the same low end of one OEM doesn't mean low end for the other OEM. So they might be starting at different trim level. They might be also having a regional limit, like depending on the OEM, where they have Europe with more safety features required and US with more comfort features required. You see a distribution on how the OEM thinks differently in the regions.
So Georg, from your point of view and from the, let's say, semiconductor point of view, doing MCUs, SoCs in this area, how do you see this, let's say, complexity moving centralized versus, call it distributed to some of the zones?
Yeah, I think the trend for centralization is clearly there. But like Emily pointed out, it's a trend. It's not a location, and where I really can just confirm from what we see right now within the architectural shifts, this redistribution or collapsing the ECUs means more or less you redistribute the functions of those. And where the processing for those is done, that really depends on the planning and the strategy of the OEM, where you do basically ADAS, IVI fusion, but as well then especially from a safety and security perspective, you probably want to have as well built in another abstraction layer. So to remove the complexity on the one layer, move it to the other where you have more safety constraints and more deterministic rather than non-deterministic behavior, where you can as well do the separation of AI for the non-deterministic versus the deterministic parts. So exactly these kind of differentiation, and then planning for L2 or L2++ and even higher. Like Emily said as well, you might want to plan for something which is where you have a base platform that serves all of those already as a base layer, but then you can scale up and add on features, but without touching basically the base layer as well, especially from a safety and security perspective.
Thank you. We're going to come to especially safety and also the different regions later on, because there is a completely different dynamic. Like you mentioned,
yep.
Safety in Europe, comfort more in the US, and there is a completely different area that's called China, which has a completely different approach. But one of the things, and this has been also mentioned in one of the slides earlier today, is which functions should never be, call it centralized, and where we should do more in a distributed type of architecture. And I would like to go first with Georg from the, let's say, interface point of view, or from the semiconductor point of view on that one.
Yeah. So multiple aspects to take into account, but two important ones is, as Emily mentioned, power consumption,
yeah.
Right? Most cars are parked most of the time, right? They consume energy when they're parked, and you got to minimize that to minimize the battery drain. So let's say safety monitoring of the battery would be an example of a function that you cannot centralize, because you don't want to activate the network unless there is a triggering event. You don't want to activate the central compute unless there is a triggering event. Another thing could be, for example, surveillance around a vehicle, like Sentry Mode. There are some implementations of that in the market where it is centralized and it consumes an enormous amount of energy. You can use it only in a battery electric vehicle. You cannot use it in an ICE vehicle. If you have some qualifying detection built into the sensors, eliminate all the false activations, you can actually save maybe a factor of 100 to a factor of 1,000 in terms of power. So major power savings. And then there's the aspect of safety, as mentioned, and battery was an example of that.
So talking to the next semiconductor, let's say, representative here, but just on a different level of integration or a semiconductor point of view, where do you see this functionality that should not be really integrated in a centralized area? And we had some discussions over the last couple of months, not just including, call it sensors like radar sensors, but also infotainment, IVI. There are functionalities like ultra-wideband, car access systems, kick sensors, parking, all these kind of things. So
Yeah, I think there's when I talk about centralization, we really need to differentiate exactly what I guess says is it really useful to centralize everything? I have to say clearly no, because there are critical elements which you need to consider in the car. And you probably have seen the Computex note of our CEO, Rafael Sotomayor, where latency is one of the things and power the other one. And latency is everything where you really talk about very safety critical, time critical applications where basically a centralization of those functions might not be possible just from a latency perspective to make very safe and critical moves within a certain time frame, right? So those are ones, especially as well, where you would like to use several sensors whatsoever, where you need to do the sensor fusion, and the sensor fusion probably takes too long if you use multiple of those. The other one is the low power concept. We really need to think about, okay, when do I need a certain function, which is the use case around it? And we talked about, for instance, for in-cabin sensing CPD. What kind of sensors do I need, and where do I do the sensor fusion, or what kind of other sensors do I need for that one? Does it make sense to use then a high centralized computer to do all the sensor fusion for a small ultra-wideband radar sensor that just uses some milliwatt? No. Therefore, the question is where to put the processing, and this is where to localize the processing for the different use cases and centralize where it's really useful, where it's meaningful, and keep the processing and the edge functions where they are needed.
So, Daniel, before I come to the glue of the two different worlds.
The hamburger.
Yeah, no, I'm not gonna say the hamburger. Otherwise, they're gonna blame me on that one, that I'm call Bosch the hamburger.
To be specific, I mean, I'll just share my opinion in the space. In general, we see in braking and steering that it's unlikely. Key variable there is latency. Yeah. In access, in some parts of telematics, it doesn't make sense, primarily because of current draw, off-state current draw. And then depending on the OEM and really depending on the propulsion system, a lot of times it does make sense to leave a modular propulsion system and to have a separate powertrain controller. Those are the big categories I would say don't necessarily make sense to centralize. We are seeing a trend, and I think you touched on it earlier, where replacing edge controllers with ECUs is not necessarily a net reduction, right, from an edge perspective. The ROI of centralizing high-performance computing, ADAS, IVI, et cetera, is quite clear, but simply replacing your body controller with a zonal controller for the cabin is kind of a net shift of the problem, not necessarily a consolidation. So I think we'll see more of a true consolidation of many of the lighting and door and seat use cases, not just to a zonal controller, but actually consolidated into HPC, but not necessarily for the topics that I mentioned, but that's just my personal opinion.
And Austin, from the tier one point of view, because you basically need to execute all these things between the two worlds, I would like to go especially for one use case, because that's one special area which is also part of the AutoSens in-cabin area, which is the in-cabin monitoring. There is one area, everything outside, but one is inside. We have the driver monitoring system, and we have, especially by law in America, the child present detection. Where do you see these two functions being centralized or non-centralized? Because both of them are some kind of safety relevant and safety critical and can save lives.
Okay, let me take this question differently. The safety you can think of safety as few layers: software safety, hardware safety, electrical safety, power safety, yeah, and finally mechanical safety. So specifically this use case doesn't have much to the sensors, the actuations in the vehicle, because interior monitoring is more a trigger to tell to the other ECUs to act differently, or to be triggered to call to the network cell that the child is left behind. It's mostly in the higher level. So you're talking about a software and a hardware. Hardware is the camera and the sensor and the compute pin. The compute is one area where we see this is getting centralized. Traditionally, it was coming as a package along with the ADAS systems, because that is where the NCAP regulations or the regional regulations come into play. Like if you have a trim level which requires user to be focused on, like driver to be focused on, that is where we started seeing it. But eventually now it's becoming a standard that every car needs to have a driver monitoring at some point. which means you need to put this compute somewhere. The camera is always in a location where it is easier to mount and easier to use it for other purposes. Driver monitoring, you can see pillar displays or on the steering or on the dash or even on the center mount on top of the display or even on the camera, right? So the location of the camera is there, but then you don't actually pick up anything new in safety there. It's just the location, making sure that you can use it for other consumer entertainment, consumer features. But when it comes to execution, you put it back on either the ADAS ECU or have a dedicated DMS OMS ECU, or we'll also see a trend that there is a lot of OEM keep the ADAS separate because you have to scale up in the different trim levels, but put it on a cockpit ECU where you can combine this with the infotainment system, entertainment system. In some cases, even surround view parking comes into part of it, where that example makes it helping that there is an additional camera connected to infotainment. Your ADAS trim level can be an L2 or an L2 plus or an L3. You still have to have that safety, which is coming as part of the default infotainment, which is anyways there in one other reason.
We had during the last, especially the last 2 or 3 years, also in the AutoSens events, when we have the AutoSens and in-cabin in Europe, in America and in China, we have this, let's say, 3 different worlds that we are experiencing there. And also most of you are experiencing exactly the same thing, the OEM from the market point of view and the chip supplier and the tier 1 from the customer point of view. One thing that you mentioned is like IVI versus ADAS. What we see is one of the big trends is like IVI is also different versions and ADAS much more different versions, like the autonomy level 2 or level, I mean, most recently we saw an RFQ, like you mentioned trim level 0, Euro NCAP 0 star. So OEMs are not even aiming for 5-star or 3-star rating anymore. They just want to fulfill the regulation, and that's about it. Of course, this will not have a big central ECU or ADAS ECU. On the other side, and this is one of the things that is based on, a little bit also based on my background, is the surrounding. When we talk about especially not the driving, only we heard a lot of driving in the keynotes this morning already. Also one area is parking. Previously, the older architectures had their own parking ECU. At the beginning, a pure ultrasonic ECU, then a parking ECU with ultrasonic and camera. Now everything is integrated in a ADAS ECU, including driving and parking. Where do you see the trend going into being centralized in a big ADAS domain controller or even high performance computer ADAS AVI together, or do you see this more like a little bit of a separation because of scalability?
I would say start with the scalability. That's actually a challenge we see in centralization of parking and driving. Yeah. In the region specifically, parking, let me break also to parking visualization functions. Yeah. Surround view, reverse camera, those are human assisting functions, whereas automated parking is actually the next step. So the basics are anyways required. So you will see requirements or even RFIs from customer with just RVC even now, because surround view can also be a premium features for certain trim line. Automated parking is actually in cases sometimes one more step up because you need more compute and also more control. There is safety element. Regional wise, there are distributions. In Europe, you see a need for more automated parking also very strongly because of the tight parking spots, versus in a bigger city in US, you have the same problem. So you need to stick with some trim line to attach parking as whether it be a separate ECU or in part of the ADAS systems. We see the trend of having a dedicated parking ECU with automated parking going down. Of course, there is a need for ultrasonics only scenarios without automated parking. So you do visualization and then ultrasonics visualization, whereas our latest generation of ultrasonic sensors also does that well. Even distance, like having some more extra distance from the traditional 1.5 meter to even much further. So you do safety along with just helping the user to park. But in the trend wise, we see mostly in case of putting either on the central compute, one chip, one ECU, or putting either on infotainment side or on the ADAS side. To add there are also the lower trim of ADAS where we still see a heavy smart camera world. So without the L2++ or the premium, still to satisfy the regional need, the NCAPs or the regional need, FMBS is an example, we still see a heavy trend of continuing that segment for some more time. So at that point, parking cannot be fully added there, but you can still integrate basic ultrasonics integration to that while keeping your surround view visualization to your infotainment. So on the lower term costs.
So moving this towards the OM. I mean, Stellar Brain is one of the big architecture that has been around for the last couple of years, and the names have been around, and the execution has been around for that one. So where do you see especially those challenges also for the surrounding parking? Because that's one of the most taking features still in the cars. Parking is like a take rate of 90% or 95% at the moment.
Yeah, going back to the DMS question, I mean, the safety criticality of DMS is really not a limiting factor in the function allocation. So DMS in another HPC, cockpit or a central HPC makes perfect sense. And I think we're sort of at the end as an industry of seeing substantial standalone DMS ECUs, right? Child presence detection is a little more interesting though, because it's really well coupled functionally with the access system, because it's on pretty much all the time and uses many of the same sensors. And I think we'll see increased coupling of CPD with the access systems. Now the point we're talking about here with parking, Austin brings up the smart camera trend that right now dominates the industry, right? If you just look at standard forward cameras, many of them are smart, and many of them are using, let's call it an ASIC from, you know, we all know who, right? You know, I think right now we're at the kind of precipice of a change in that ecosystem, a significant change in that ecosystem. And again, referring back to the press releases we had just a few weeks ago, we've sort of put our stake in the ground of where we think that's going to go, right? So we believe that forward-facing ADAS is going to be centralized, and that it is going to be a software stack, not an ASIC, right? And that's very clear. We announced that publicly,
Yep.
right?
Yep.
Where is the industry going to go? Well, I guess we're going to have to see, right? Because it hasn't really re-standardized yet from the current standard. But I would argue, and I'd love to hear others' opinion, that we are definitely at an inflection point right now where when we look out in that 2030 timeframe, I do believe that a new standard is going to emerge, and that the current ecosystem of having in many cars an HPC with cockpit and part of your body control, and then a forward camera with an ASIC is nearing the end of its dominance in the Western world. I'd love to hear what you have to say about that, though.
Yeah. So who are people looking to, right, for guidance here? And when it comes to autonomy, a lot of eyes has been on Tesla, right, in the past. Sure. Now, I think a lot of eyes are on China, right? ADAS scaling level 2++ in China has been intense over the last year and a half, 2 years. Yep. And the trend that I'm seeing there is centralization across the board. In many cases, multiple SoCs in the central compute. In the simpler cars, even just one SoC in the central compute. So I think it's worth paying attention to that, and also to the point that Prem made, going from Xavier to Thor, 60x improvement in compute capacity. That did not mean 60x increase in price. So this is one of the capabilities that is falling the fastest in terms of cost. And long term, I think that'll, you know, talking about cost as a motivation to split up systems, I think it's a thing that over time will go away.
Before we come, and that's going to be, thank you for that bridge already, because that's going to be one of my next questions about the dynamic in China. I just want to give Georg also a chance to give us a little bit of the NXP insights on, let's say, this parking surround view, let's say low-speed maneuvering, call it low-speed maneuvering area.
Yeah, on the parking side, and you mentioned just China, and what do we do with in terms of centralizing intelligence, sensor fusion. I mean, there's no secret about it because we made it already public. We basically were able to use basically ultra-wideband radar technology to replace ultrasonic sensors in combination then basically with the camera that's anyway available and doing sensor fusion with the camera and the ultra-wideband radar, which is based on the same platform like ultra-wideband for secure car access. So we are reducing the cost in basically adding software modules on existing hardware, doing smart sensor fusion, and therefore we are able to kick out other sensors. So this is exactly when we're talking about cost down. This is what we are trying to drive there. China was very eager to experience that and is already rolling this out. I think we can do as well much better in other areas. The other topic about this is when we're talking about centralization of sensor fusion and so on, we're always talking about active or still driving mode capable, and parking is still a driving mode. When we from NXP are talking about park, we think about the state of the car as a park mode or even as a living mode. Due to the battery electric vehicles, we're right now, everybody says, we have enough energy. Oh, that's easy, milliwatt, we don't care. Guess what? Combustion engines will live much longer than everybody anticipated right now, and those have only this small 12 volt or in the future probably a 48 volt battery. There's not that kind of power budget. So when we're talking about the park mode or the living mode, we still need a lot of inside sensors, and then we're coming back to in-cabin sensing. And where do we do now the sensor fusion? If you're going to use the sensor fusion within a high centralized ECU with NVIDIA Thor or Orin, guess what? Your battery drains like a hell. And Emily was showing it in terms of how to balance correctly the centralized compute and putting the intelligence where it's needed, as well as, and this is what I mentioned before, you need to rethink about the architecture, redistributing the functions as well as the sequence when certain functions are necessary, put them where they are needed at a certain time, and then you achieve both the accuracy, the latency, as well as the power efficiency.
So between those four sensors, right, the overlapping sensors, surround view camera, ultra wideband, radar, and ultrasonic.
Yeah.
Yep.
Which ones do you think will survive to 2035?
That was.
Oh, I'm sorry. I take it.
No, that's fine. Perfect. When you start discussing, that's even better than me asking questions.
What do you think?
What do you think? Which sensors will survive? You mean especially the low speed?
The low speed, yeah.
Low speed area.
The four corner sensors that we have on many four corners.
Yep.
So radar per se, so the standard 77 gigahertz or probably in the future 140 gigahertz radar sensors, they will survive. They have cleared their capability, and with the capability of switching between antenna arrays and so on, you can directly nicely switch by software, right, with one hardware, just with software on long range and short range. And in the combination with camera, so you will not get rid of camera. Camera has a very clear value proposition, and you will need this for the perception part. So no discussion about the camera. From my perspective and NXP perspective as well, radar will stay there. We will have radar there. Ultra-wideband as a technology is already used in multiple areas as well outside of automotive. Well established in the industry for robotics, for home appliances, and so on. I guess we will further see a cost downstream of ultra-wideband, and therefore as well ultra-wideband will have its broader space in that one. I see ultrasonic sensor in this case critical, while it still has certain areas, but I think in the sensor fusion, probably ultrasonic sensors might drop out.
Thank you for the question, because it perfectly helps me to bridge to my next question, which is about especially not just the OEMs, but also the tier ones and the semiconductor suppliers, how they're gonna balance the speed between the China innovation with also the automotive long life cycle termination, the next generation of sensing and compute architectures. And I would like to, because most of you have not been there, I give you a little bit of insights. When we started the AutoSens in China 3 years ago, or 2.5 years ago, the opening keynote speech has been made by VCTC, Volkswagen China Technology company, which is completely decoupled in the meantime from Germany. So it's Volkswagen China for China market, and maybe starting end of this year, even outside of China. The second keynote speaker was NIO, one of the EV manufacturers and EV producers in China, also available and globally selling. NIO showed in the first step their NIO supercomputer called Adam, which has 4 Orin X on one PCB. In the second half of the presentation, they presented the NIO SoC that they developed by themselves, including all 4 Orin X power into one dedicated SoC. What scares me a little bit, and I'm from Austria, we have no car manufacturer. I mean, officially. Secretly, we are the owner of Volkswagen, don't get me wrong, but that's what it is. But what scares me really is we in Europe and in America talk about architecture 2030 and beyond. If I go to a Chinese tier 1 supplier, he smiles at me and says, okay, when you want to talk about SOP 2030, come back in 2080 or 2029. The design cycle in China is 18 months for SDVs right now. And for IADVs, we talk about 12 to 13 months design cycles right now. How we gonna get as a American and European OEM tier 1 semiconductor point of view, because it affects everything and everybody, gonna keep up the speed with those guys? How are we gonna see this innovation? How are we gonna get to the same pace, and maybe from the OEM point of view, because I mean Stellantis is probably has not the biggest market share in China, but the Chinese OEMs are coming here, the Chinese tier 1s are coming here. We see the OEMs in Europe releasing RFQs to China tier 1 suppliers and semiconductor suppliers, which is affecting the other guys. So how do you see that balance of speed versus innovation versus, let's say, legacy OEM point of view?
Yeah, I mean, certainly there's always things to be learned from your competition, right? And one of the cool things that's going on in China is there's a lot of competition, right? There's a lot of different OEMs. It's a very cutthroat market, and there's a lot of learnings that I think the entire industry can take from that. So don't get me wrong, you know, taking those learnings is important. But fundamentally, do you want a car that was designed quickly, or do you want a car that was designed right? What is the benefit to the customer of a 12-month shorter design cycle? Because we can see the costs, right? Yep. We see that in the quality reports out of Europe right now, where we're seeing direct competition between Chinese and European built cars. And there are major quality issues. The Chinese cars coming into that market, and of software that when the car is shipped is not done. As a consumer, do you want that? Is that a value proposition for you to say, this car was shipped to me before it was completed? I guess that's a customer decision.
It's worked out well in consumer electronics, but consumer electronics usually don't kill you. So that's a
and they don't
that's
last
a big
14
difference.
years.
Right. So I think the key benefit that you get out of a short design cycle is that the car that you receive has modern technology in it.
Sure.
If you take 5 years to develop a car, you decide on your feature set 5 years ago, a lot happens in between, and you don't capture that benefit. So you can go about it two ways. You can have a development process that actually allows you to bring in new features along the way, so an agile development process. Or you can hurry like they do in China with their 996, their local value chains, and the ability to bring on any supplier on site within a few hours. Right?
Yeah, I mean, totally agree, right? And as much as I'm a bit biased, right? You know, I'm responsible for technical strategy at Stellantis, so you can imagine my bias towards technology, right? But I imagine our average customer doesn't buy the car to play with the infotainment system, right? There's value. The value of a car is mobility, And what we offer in technology is supplemental value on top of the key value, which is mobility. And you saw in Emily's presentation, our strategy is very, very clear, right? Focus on high quality cars. And you probably heard that in the announcement from our CEO. Quality and time, right? It's the old adage, right? Quality, time, cost, you get to pick two, right? Yep. So as you see from Emily's presentation, we centralize compute that gives us the flexibility to add features, that gives us the flexibility to build competitive technologies in our customers' hands without necessarily focusing on rushing. Now, don't get me wrong, as the ecosystem is able to move faster, of course, you want to learn from your competition, you want to learn from the things that are doing well, but I would not call the 0-day updates and 6 months of not having features actually active after SOP as something to copy, right?
Yeah. And there are OEMs that refuse to go global in China because they know that they're gonna have potential quality issues or they may face some difficulties with the legislation. So
even the Chinese government recently announced what basically summarizes as, can you please finish the cars before you sell them?
It's the new regulation that has been drafted for July 26 and will be released in January 27. So the European Union is negotiating releases like that for 5 years, and the China government is releasing it within 12 months and say, starting 1st of January 27, this is what you have to do.
Yeah.
Period. So
yeah, I think there's one additional aspect to this. When you look to the China OEM market, right, it has a totally different history than what we have in US or in Europe, right? There's a legacy which is sometimes a burden, sometimes an advantage when I'm talking about quality, safety, security, right? This is where US and EMEA brands are proud of, where everybody says, yeah, China, I don't know. But let's be fair. China is as well using high quality suppliers like Bosch, right?
Yeah.
Like NXP, like NVIDIA, and so on. So they're using the same kind of technology which we as suppliers make available to OEMs. Mm-hmm. So claiming that we have the much better quality, okay, in certain areas might be the case, I agree, but on other things, their big advantage is they can decide, or they are deciding significantly faster because of a low legacy that they have to maintain. Right now, how to solve this right now for our legacy OEMs, I think what you just said in terms of centralizing, starting to do exactly what China has been able to do immediately because they started new on scratch on the greenfield, right? Was being able to immediately say, okay, this is the technology available, I do it. Right now, we had to learn how to collapse and consolidate ECUs, redistribute functions, build up a harmonized software. I think this is exactly what's starting right now, or where we are today. And this is where we, as well from NXP perspective, we see our duty in providing such a scalable, flexible portfolio that helps OEMs and tier ones to build up these modular, scalable platforms, to do the abstraction layer for safety, for security, but then as well keeping the scalability and flexibility towards scale up and down in a way where you're building it up on one harmonized software platform so that you benefit from a very stable, robust, we call it vehicle core, but then have the flexibility in sensors, IBI, aiders, where it can adapt much more flexible to the environment. I think then we can, as well, legacy OEMs can nicely speed up and accelerate and get on par with China OEMs. And then with the quality and safety that you have already in place, I think then you're well equipped.
So speed is a big thing there. You mentioned about 18 months, long time, right? We see trends that the ECUs are asked for 1 year lifetime. So the development time is just 1 year. So start to launch or start to source to launch is like actually 1 year.
1 year.
We see very tough to meet there, but we still see benefit of doing a fast development. But then at some point, the 1 year might not be the right time. 3 year might be a little long. There is somewhere a time in between which might be the right time to enable the quality, also bring in feature. One big advantage, the Chinese OEM, some of them, and some of the Western newcomers, which the legacy OEM who comes with a legacy in a positive way, got differently is they started from the greenfield approach. The benefit of that is that they don't have to carry the legacy which you mentioned. But the bigger thing was the start point of those OEMs were right in time when the technology was going up, the ADAS levels were going up, or ADAS features were going up, the display technology, the infotainment technologies were going up, and finally now with the AI trend, They were also in the time that they are like starting from scratch. How do we design from scratch? Going back to the example of NIO developing from the Orin to this one, right? The bigger challenge NIO or any other OEM is going to face in that transition is how do you maintain this NIO car with 4 Orins after 7 years versus how do you develop the new one? And we see that for all the OEMs who do 4 cars well, you can't update your hardware so easily and keep maintaining your 5 generations parallelly, keeping the 14 years which Stellantis will maintain, the GMs will maintain, right? That transition China have not seen much because they are now into selling mode, less into maintenance, and once the maintenance come into picture, we'll start seeing that the OEMs get the reputation going down. The legacy OEMs have a good chance to keep up the long-term quality. So legacy will remain a legacy, and some of the newcomers will be quality, eventually learn the quality aspect and continue stronger to compete with the legacy at that point.
We don't even know how they're gonna utilize and how they're gonna manage like the lifetime, like 6 years, 7 years, 8 years spare parts program. I mean, all of us know the difficulties when you sign a contract with a global OEM where you have a spare parts program of 25 years. I mean, some of the OEMs in China will not be here in 25 years. That's the other thing that
Quite a few, I bet.
Yeah, I mean, we have 109 OEMs in China right now, to give you an idea. It's quite a number.
Yeah. And you mentioned the life cycle, and I think there are some interesting aspects to that. Over the last year, we've seen at least 2 OEMs that actually had to do mid-life cycle upgrades to hardware, i.e. rip out compute hardware and replace it with more powerful hardware. And that's one thing that we don't talk much about, right? Building in future-proofing, enough communication bandwidth, and scalability in the compute power, so you don't actually have to rip anything out of the car, but you can add to it. And for a product that's going to be in the market, let's say, or that has a life of 15 years, right? Compute power is going to go up another factor of 10 or maybe 100, I don't know, a big number over that time. Software is going to get much bigger. We need some scalability vector in hardware, I think.
I know we're gonna be able to discuss and talk about this forever, probably for the whole day. I would like to close this with one question from the ADAS point of view in future. The architecture, what do you think will be the main driver? Will it be AI workload, or will it be the regulation and safety requirements? I'm gonna start here.
What do you mean the main driver? You mean by volume?
No, for the development. Really, what's gonna drive the development for the ADAS architecture?
The product launch still.
Yeah.
I mean, it's sort of bifurcated, right? You mentioned this earlier, actually, that there's a lot of cars that are targeted to just meet the bare minimum ADAS requirements, right? Because the market's, it's kind of bifurcated, right? Some people are saying, hey, I want a car, and I need that car to get me from A to B. And I'm not necessarily terribly attracted to new ADAS features, right? On the other hand, you see, I want a car, and I want L2++, right? Those two designs are very different optimizations, actually, right? And one thing I'd say is, I don't think a lot of people buy cars because of differentiation in the L2 field, right? L2 and below. They don't say, you know, this OEM is a really awesome L2 system, right? In general. And so there, it's very much commoditized, right? And your design philosophy is how can I achieve very high volume and a very competitive cost? And performance is not necessarily as important. You need to meet the regulations, but you're not going to differentiate based on performance. If you look at the L2++ field, the opposite is true. The difference in performance between the different L2++ solutions in the field is quite significant. And that is a real difference to the user, right? And they're designing in order to achieve the art of the possible is the goal, right? And you saw that with our recent announcement with partnership with Wave, right? And we're really pushing that boundary of what's possible, right? So for me, it's bifurcated. And I think both will happen, but your average car is more impacted by regulation than the art of the possible.
Yeah, I think Daniel summarized this very well. There are cars where you need to differentiate on ADAS, and then there are cars where you just need to meet regulation. Those who just want to meet regulations will use third parties for their ADAS solutions. Those who want to differentiate on them want to own that.
Okay.
Adding to Dan's point, I think what he told is exactly right. You see the base cars still continuing with the smarter L2 system, which is pure safety, no comfort, and the branding cars or the high-end cars coming from with L2++. AI will be heavily used there, and this will be more like a role-based system, the ASICs or the different technology. We'll continue seeing that cars because there is a price aspect, right? Every consumer cannot afford the higher one. And when there are OEMs who don't have to scale for different trim levels versus the legacy OEMs who still have to scale from the entry trim to the higher trim, you'll see this broadening versus the new car lines like the Chinese or the new brands here. They don't have to have that scalability. They try to, yeah, my brand image is better, so I'll put every car with AI versus legacy OEMs still continue to put these in the small cars.
I basically have a twofold answer to this one. So adding on what has been said, currently mainly regulation was as well one thing that is driving it as well when you're talking about L2+ and then even going higher, right, in terms of the amount of sensors we need for redundancy and safety and whatsoever. That is creating a very complex ADAS architecture. Now looking from the AI trend perspective, right now there's still not a real solution for AI for safety. This is under debate. I think as soon as, and then looking into the development of LLMs, VLMs, and now recently as well VLAMs, right? They are improving at a speed that nobody has anticipated before. So what is coming next in the next 1 or 2 years based on AI in improving AI for safety, improving AI for ADAS? I could easily imagine that within the next 2 or 3 years, AI is taking over defining what an ADAS architecture finally really needs, because we will see how much more efficient AI can be as well for ADAS purposes. And then as soon as we have AI for safety as well available and approved, then I think we will see a major shift in terms of these kind of architectures. But that's just a pure assumption, right? Assuming that AI will change significantly our future.
Adding to that, we still get RFIs from the OEM asking for the lowest trim, which is purely L2. Which we have in the production, and we have new generations coming out, the smart camera or a detached camera with a minimal compute. So just L2 functions, camera attached or detached, but the same compute in that sense. And we still have production and the development programs with not the end-to-end AI, but the basic L2+ and some old style L2++ with minimal performance. But we also have the end-to-end development for other OEMs where we don't care about the L2s, we need it in the vehicle, but the development of AI is fully on the higher end, L2++. So we see all three coming and all three going for this. If you buy a car in 2030, you'll find all these combinations.
I'm looking forward to have a similar discussion with all of you again here on the same stage next year. I think one thing is clear, safety is not negotiable and it has to be given. So thank you very much for contributing here. Thank you very much for your time. Thank you.
Thank you.